So it's nice to be back here. I think I came here the first time in 1981, so I'm getting old, I can see that. But it's also interesting to see how this institute has developed from this corridor up in whatever the hall it was called to this fantastic place. So I shall try to find the right place to stay. So what I will do is that I will tell you more about sort of the background about to the Nobel Prizes. Of course, what you see is this intense week in October when people are waiting, many people are sitting up waiting for telephone calls, but I will try to give you a little bit more of the background. And I will also tell you about Alfred Nobel, because it's an interesting story in itself, and it also gives, you know, sort of an understanding why he introduced these prizes. So Alfred Nobel, he was born in 1833 in Stockholm, and he died at the age of 63 in San Remo. He was a chemist, engineer, innovator, armament manufacturer, and the inventor of dynamite. And you will hear more about that soon. And it's even remembered in physics for this element number 102 as nobelium. That he had nothing to do with. So this is the house where he was born. It's in the middle of Stockholm. It's a typical house from that time. And his parents, his father, Immanuel, he was what you nowadays call an entrepreneur. So somehow, when he was, with good money, he could even afford to have a picture of him. This is a painting of his mother, so there are no pictures of her. And so Immanuel, as I said, was an entrepreneur, and in 1838 he went bankrupt. So he moved to St. Petersburg, and for 4 years the family was still there. There was Alfred and his older brothers. And his mother had, to very small means to keep the family. But once he had established himself in St. Petersburg, he was very successful with the mechanical industry. And there's even a picture of the house where he lived in 24 Petrogradskaya embankment. I don't know if Arkady or someone had been there in Leningrad, as it was called later. So they lived there in this house up to 1859. You can see it's a big house. It was rather lots of money in the family, and Alfred had private tutors. So he became fluent in Swedish, French, Russian, English, and German. And he learned later Italian. So he was very interested in literature. But he studied chemistry, and his father wanted him to study chemistry. And in 1850, he was only 17. Then he was sent out to Paris and also to this country to study chemistry. So this young guy was sent out. It's non-trivial. I mean, so he was out, I don't know for how long. And, it was a very successful trip for him, because when he came to Italy, he learned about nitroglycerin, which had been invented in 1847, and he took this knowledge with him back. Rather clever of a guy, 17 years old. So he came back in the 1850s. Then it was the Crimean War, and his father was very successful during the Crimean War, at least in the beginning, because he sold weapons to the Russian army, some landmines and things like that. But of course, the war was not so such a good thing for the Russians. And after the war, again, his business went bankrupt. So that's why they had to leave and go back to Sweden in 1859. And two brothers stayed on in Russia, and they founded the Russian oil industry. And at that, later, around the turn of the century, they were probably even richer than Nobel was at the time. We can come back to that. But they lost everything in 1917, of course. In 1964, they had set up a factory producing nitroglycerin outside Stockholm when the whole factory exploded. 5 people died, and among them his younger brother. And of course then authorities were suspicious. These were very dangerous things. On the other hand, the industry at that time, they needed something to blow up things. So he then, in 1867, invented dynamite. So he took nitroglycerin and incorporated it into what is called diatomaceous earth. And then it became safer, you could handle with it. Still it can explode once in a while, but not at all as much. And so this was a fantastic patent that he got. From that point on, he moved around the world, and he settled in Paris. So this is a picture from his apartment at Rue Malakoff in Paris. The house doesn't exist any longer. Here he had a salon. He was meeting with all the interesting people. But it was working extremely hard. So over the years he founded factories and laboratories in some 90 places in more than 20 countries. So although he lived in Paris, much of his life was that he was constantly traveling. So Victor Hugo at one time described him as Europe's richest vagabond. And when he was not traveling or engaged in the business activities, he was always working in the various laboratories. Wherever he had some factory, he set up a laboratory, and there he was working on new inventions. And so at the age of 43, he was feeling like an old man, and he had not had much of private life. So he advertised for the secretary and supervisor of the household. And so he got an answer from a woman. Bertha, her name was then von Kinskesen, rather long Austrian, Her father was a field marshal, but had been becoming very poor, and she had to work in the von Suttner family as a teacher for their younger son. And they had got romantically involved, and she had to leave. She came to Paris, was there for a week, and there was a new life for Alfred. They discussed literature, they discussed peace, they discussed all sorts of things, but then she left. And she eloped with this guy von Suttner, and they got married. They were staying outside Austria because they were not allowed back because of his parents. And they devoted their life to peace conferences. They were organizing peace conferences. This was something in the late 19th century in Europe that people were very interested in peace. There were all these movements, and she was somehow one of the leaders of it. And she eventually wrote a rather famous book called Waffen nieder. I don't know what's the English. I don't remember. Anyhow, she would eventually become a Nobel laureate in peace in 1905. So we're coming back to that. But now Alfred had been got interested in a bit female people, and he met a young, also from Austria, Sophie Hess. And she was an uneducated lady. She was 20 years old. This is mid-70s. And somehow they had a relation. And people have tried to do as much as possible out of that. I think what it really was that she was, of course, using him to live a very, very privileged life. And it took him many years to somehow get out of that. And so this is about as much as we know about his private life, during those 63 years. Then in the late 1880s, he got in trouble with the French authorities because he sold weapons to the Italians. And there were all these troubles down at the Mediterranean about where the border should be. So somehow he was not very welcome in Paris. So he moved to San Remo, which is of course a wonderful place. And if you ever go to San Remo, you should go and see Nobel's villa. It's in the outskirts of the city. This is still there. It's a museum now. And there he spent most of the time when he was not traveling in, say, his last 8 or so years. Also there he set up a laboratory. And he was interested in some gunpowder at the time. And he had a big cannon in the garden. And he was practicing by shooting out, this is next to the sea. So, but there were lots of fishermen there. So he was always sort of passing them, but they were not very happy with him at the time, as you can imagine. But, so you can see he was devoted. But he had been away from Sweden most of his life, essentially. And he still had this connection with his mother for some time. He used to go to Stockholm once a year. But then she died, and then he thought he should have some kind of connection to Sweden. So he bought a big mansion and a small factory up in the western part of Sweden called Björkborn. And again, he set up a laboratory. And this became eventually one of the big weapon industries in Europe, selling cannons to both sides in both the wars. I don't know if you should be proud of that or not, but it's... But he was an idealist even, so he said this statement, which you should really look at. My dynamite would sooner lead to peace than 1,000 world conventions. As soon as men will find that in one instant whole armies can be utterly destroyed, they surely will abide by golden peace. We now know how true that is. But this was sort of, it was not just an excuse for what he was doing. I think he believed in it, As I said, he was interested in literature. And he once even wrote a play called Nemesis. And he tried to get it published. Nobody wanted to have it. And eventually the Nobel Foundation published it in 2003. It's supposed to be one of the worst plays, ever published. So I think he was a better chemist and innovator. So he was an innovator, we say. And he was awarded 350 patents, which at that time was an enormous number. But it was his best invention, was a Nobel Prize. And his will, which was signed in Paris in November of 1895, it's very short. He had been changing it a couple of times. And so you could see how it developed into what I will now show you in more detail, or what it amounted to. And you will also see that the influence of Bertha von Suttner came gradually into it, because in the beginning this Peace Prize was not there, but it certainly is there. So this is essentially the text translated. And let me just give you. It says that the interest on... he said, the whole of my remaining realizable estate shall be dealt with in the following way. The capital invested in safe securities, I can come back to that, by executors, shall constitute a fund, the interest of which shall be annually distributed in the form of prizes to those who during the preceding year shall have conferred the greatest benefit on mankind. We can come back to that also. Then it starts with it should be 5 equal parts, and there should be apportioned as follows. 1 part to the person who shall have made the most important discovery or invention within the field of physics. Is it discovery or invention? 1 part to the person who shall have made the most important chemical discovery or improvement. 1 part to the person who shall have made the most important discovery within the domain of physiology or medicine. The only discovery. And then comes the other, which are more problematic. 1 part to the person who shall have produced in the field of literature the most outstanding work in an ideal direction. We can discuss that afterwards. And 1 part to the person who shall have done the most or the best work for fraternity between nations, for the abolition or reduction of standing armies, and for the holding and promotion of peace congresses. There it came. And then eventually it says, no consideration whatever should be given to the nationality of the candidates, but that the most worthy shall receive the prize, whether he be Scandinavian or not. So, a year after he had written, on December 10, 1896, Alfred Nobel dies alone in San Remo. He was there with some servants, and his assistants, or they were not there. He had in 1890, he had got a new assistant called Ragnar Suman. He was an engineer, and he started to work for Nobel just after he had graduated from this Royal Institute in Stockholm. And in the will, he was named as one of the executors of Nobel. He was very surprised, He was 26 years old, and the other one was an industrialist in Sweden. And so he came quickly to San Remo, and this is a very fascinating story, what happened then. He comes to San Remo. They didn't have internet at the time, so the French authorities did not know that he was dead. And they didn't, communicate it immediately. He went to Paris. He collected, he went to all the banks to try to collect all the assets that Alfred Nobel had there. He was going, in a couch, and we had 2 guns with him. And somehow he managed to get it without the authorities getting to know it. What was the problem? Well, the problem was that the French tax laws were very strict, and and I'm coming back to that. So he also went to England, to Germany, and he managed to ship everything up to Stockholm. Because in Stockholm, the tax rules were, for a will like this, there would be no tax. In French, it would have been a huge tax. And so, of course, the French authorities questioned it, and there were all sorts of illegal work, to be done. Should it be counted as a Swede or French or anything? And somehow, just because he had bought this place I told you about in Sweden, somehow the Swedish authorities said he's Swedish. This is where his address. So in the end, Suma managed to get all the assets there, but then there came more problems. The family, his brothers, as I said, were very rich, but there were parts of the family that were not that rich. There was an enormous amount of money at the time. So they they questioned it. And the king was very upset because, as I told you, it was saying that it should not be given to Scandinavians, but to the ones who deserved it mostly. And the king was very much against that. And then the third point that came was that if you look at the will, it says that the interest should be given, but who should handle the interest? Or who should handle the fortune? The money was not donated to any person or organization or anything. But they solved it by setting up a foundation, the Nobel Foundation. And after about 4 years, the process was all in order. And this is what I'm saying here. So the Nobel Foundation was set up. And then came the next problem. He had said, in the will, who should be the prize awarding institutions. For physics and chemistry, it should be the Academy of Sciences. In medicine, the Karolinska Institute. Literature, the Swedish Academy. And peace, the Norwegian Parliament. Up to 1905, between 1850 and 1905, there was a union between Sweden and Norway. So Sweden was having, they took care of the foreign policy, but Norway had a parliament. So somehow it was a gesture to the Norwegians to give the Peace Prize to them. And the Norwegian Parliament, they were very happy. The Academy of Sciences was very unhappy. They didn't know what to do. They were having all sorts of troubles. And it took quite some time to convince the members that they should do it. And the only way to do it was to give some money, to set up some Nobel Institute, so that the physicists and the chemists would have, enough money to do the work. So in 1901, the first prize in physics was given, and it was given to Röntgen, which was I think another thing we were very, I should say, lucky in the sense, because it was a good prize. It was a very well-known discovery, invention, and both, He had done the discovery in 1894. Röntgen was, he was not young at all when he did it, but he became very famous during the late 1890s, and was an obvious choice. That helped a lot. In principle, they were doing very well, the first few years. As you can, like in 1902, there was the first theory prize to Lorentz, who was, regarded as the most important theorist in the world at the time, and also to his student Zeeman. That could be questioned, but there was strong pressure for that. And then, of course, in 1903, with Madame Curie and Pierre Curie and Becquerel. But in 1801, this is a picture from the ceremony. It was 180 men there, no women, and the king was not there. Eventually, the king started to come, and I think he now likes it. Well, they've been liking it for a long time. So let's look about physics. So you said that one part of the person who should have made the most important discovery or invention within the field of physics. And so how do we interpret these things? Most important discovery. So it's not a lifetime achievement. That can happen in chemistry, because improvements, you can improve, for 20 years, and then and there are such prizes. Someone is really good. It's not the second discovery who did it much better or understood the whole thing, No, it's to the first. And it's also not to the one who did the most beautiful experiment. I will give you an example of that. And then it's this which is, you cannot read from the will, but that was an interpretation of the physicist in the beginning, and it's been going on like that. Not a theoretical discovery that has not been experimentally verified. There are theoretical discoveries, which we believe in, but somehow they are not. It's not possible to give it. And there you should also remember that in academy there are many more experimental physicists than theorists. So that cannot be changed. So the upshot is that it's not always the best physicist who gets the prize. But as we say, you don't need to be an Einstein, but it helps. So let me give you some example of the development. Arnold Sommerfeld, he was such a pioneer in the early quantum physics. He was advisor to all the famous Germans who eventually got the prize. He was in Munich. He was a leader for a whole generation of German physicists. He was heavily nominated, but he was not given the prize. And in retrospect, what should he be given to? They could probably have given, but they took that very seriously, the discovery or invention. John Wheeler, of course, in the United States, had been a very important person. He was also an advisor to many. He was advisor for Feynman. So they were leaders, but they did not become laureates. I can always question. And it's not for the collected work, So Albert Einstein got it for his services to theoretical physics, and especially for his discovery of the law of the photoelectric effect. I can tell you that if you really check on the web, there is this nobelprize.org. And if you learn to maneuver the page, you can see that now you can check the nomination, who nominated whom, and up to 50 years ago. And you can see how the nomination, the pressure for Einstein got bigger and bigger. And if you look at that, you might say that the committee must have been stupid not to give it to it before. But again, then you have to remember that, as I said, it was dominated by experimental physicists. Many of them didn't like the modern physics. In Sweden at that time, theoretical physics was modern physics, whether it was experimental or theoretical. And they were very much against it. And so as a compromise, in a sense, he got it for his discovery of the law of the photoelectric effect, which is a wonderful discovery. It's a beautiful paper and everything. So in a sense, it's a correct way of giving the prize, but it could have been given to other of his discoveries. In the case of Hans Bethe, it was given for his contributions to the theory of nuclear reactions, especially his discoveries concerning the energy production in stars. Because this is just one of those things that Hans Bethe did. And again, if you cannot read the paper behind, but if you do it, you will see that they had some difficulties. What should they choose? Somehow they had decided, I would say, giving it to him, and then they have to find which discovery should be. So, but that was correct, Not for the most beautiful experiment. I'm always taking up this Pound-Repka experiment, as you might have known. It was done in the physics building at Harvard when they were sending photons from the 6th floor down, and they were checking the time dilatation. And so the difference in how quickly the time goes here and there is 10 to the minus 15. And they did it in a marvelous experiment, very beautiful. But it only confirmed the equivalence principle, and that was part of Einstein's theory. And in that sense, it was not really a discovery as such. However, of course, they used the Mössbauer effect to do it. And Mössbauer got the prize in 59, I guess. So again, that's and this is what I said before, not a theoretical discovery that's not been experimentally verified. This paper by Stephen Hawking is, of course, one of the most famous papers in physics, particle creation by black holes. It's a fantastic discovery, I think everyone would say. It's obviously correct, but it's not been experimentally verified. And Stephen is not too happy about that, as you know. Then a discovery should have scientific height. It should be a watershed. You know, you should typically have a before and after. Then it's perfect. And Lee and Young in 1957, for their penetrating investigation of the so-called parity laws, which has led to important discoveries regarding the elementary particles. Since they both are alive, you cannot check. You cannot even check, you know, how many nominations they got. But you can think. You know, their paper was from the summer of 1956. The experimental results, Madame Wu's experiment, and also the other two experiments, they were neck to neck were reported on January 15th. And the nomination should be in by January 31. And they were very young, as you know. I guess they were, let me see, they're 57, they were 35 and 32 or something. And they were, of course, it was such a fantastic thing to give it to them at the time. But you might have questions about it later. I'm expecting that, so you can do that. We like to point to one paper. And Hannes Alfven got the prize in 1970 for the Alfven waves. It said, for fundamental work and discoveries in magnetohydrodynamics with fruitful applications in different parts of plasma physics. This is his paper. Half a page in Nature, 1942. And if you look more into it, you'll see that here, Maxwell's equation. Here is the hydrodynamic equations. And then he combines them. And he gets these waves. And it is, of course, important, very important in plasma physics. These are the plasma waves. So this is a perfect example. You know, they used to be saying about Alfven that he was a man who had 6 million ideas. So at least one of them had to be really good. And this was a good one. But also, in more modern times, the prize in 2013 to Engler and Higgs, with the longest motivation in the history, for the theoretical discovery of a mechanism that contributes to our understanding of the origin of mass of subatomic particles, and which recently was confirmed through the discovery of the predicted fundamental particle by the ATLAS and CMS experiment at CERN's Large Hadron Collider. And if you look at their papers, of course, Braut and Engler's paper, what they do is that they compute these two Feynman diagrams. Very easy. But they did it in the right way. You know, that you could have thought that they should just put it as into the propagator. No, what they did is they took them as interactions, and in that way they could use spontaneous symmetry breaking, and they could see that you get the mass for the vector particle. Peter Higgs did a classical analysis, and he was introducing a new field like that. He was coupling a vector field with a scalar field. These are, you know, vector fields and scalar fields. And so he introduced this. He got the field strength, and he got this equation, the Procca equation for a massive vector particle. This was essentially it. So you see these work, you know, where it's, and you can also see that it, in a sense, it's the before and after on all of those discoveries. So let me now go to the procedure, because you're interested in that too, I hope. So the Nobel Committee for Physics has 5 regular members, the chairperson, and there could be a joint members, and there is a secretary. So, you can see that I wrote this talk after 2013. So this was the committee. The committee consists of Swedes. We often get this question: why don't you have some foreigners in the committee? You might say that it's a French name here, but she's working in Sweden. Well, Olga Butner is originally coming from Poland, but she is also a Swedish professor. And and of course, the good thing of having a committee talking Swedish is that we have a secret language. We can use that. So the whole procedure for 2013 started in September of 2012. So the committee we sent out about 3,000 letters to physicists around the world. We have a scheme by which we try to cover all universities that we know of. Then with institutes, it's a little bit more difficult, and there we usually try to have people. We try to find specific people in institute, like this one or other institutes. Then, let me see what members of the Academy can invite members of the committee, previous Nobel laureates, and some of them are very good, even present in the room, and Nordic professors. Of course, when it started, there were a few Nordic professors, and now there are hundreds, and many hundreds, I guess. And then, as I say, physics professors at selected universities. And those change every year. I should say that we have this other list also of people whom we ask, for a number of years. So how does it work, the committee? Well, by evaluations, either by committee members or assessments by external experts. So we usually write about to 20 people around the world, asking for their opinion about someone's work, about the field, who did this, and rather specific questions that we want to get confirmed, say, and that's working very well. We ask them to be confidential, and in almost all cases they are. So we want to know this prize-worthiness according to those criteria I told you about. So this is a procedure that goes on during the spring. These letters are sent out typically in March. We are asked to have a report by the end of May, and during the summer we go through them. And then eventually, every year, we write a rather comprehensive book reviewing essentially all fields of physics. And this is, of course, it's not a new book from one year to the other, because we can carry over a bit with the help of computers. It's easier than I don't know how they did it before. They probably used the scissors and they copied them. But it goes through the basic fields every year, and eventually in August the committee is working on it, and the committee makes the proposal by the end of August, and then it can be accepted or rejected by what we call the physics class. Those are the physicists in the Academy of Sciences, and they meet twice in September. So there can be two recommendations. It could be that the committee has one recommendation and this physics class has another. sometimes they can only differ by a word in the motivation, of course. But they could, in principle, be completely different. And then the final selection is in a plenary session the first Tuesday in October. And then there's a prize award ceremony in December. And so there are regulations. There could only be 3 laureates. It says 3 laureates. Actually, it said in the Swedish text 3, it says. And in the English text, it was wrongly written as 3 persons. But it says 3. And the prize sum is, in these days, 8 million Swedish crowns. It's about, these days, $1 million. And as we said, deliberations are secret for 50 years. And in physics and chemistry, there has not been any prize to organizations or large collaborations yet. But this can be decided by the Academy itself. So Norway already, like 1906 or so, decided that it could be given to organizations. I think that was the first time that the Red Cross got it. But in physics and chemistry, it's not been decided. And as of 2013, you can see there were 47 prizes to 1, 31 to 2, 29 to 3. And of course, there's a timeline for that. In the beginning, it was almost always just one person. In 1933, there were to Schrödinger and Dirac. That was a rather heavy prize, to 2 people. Actually, it was delivered at the same time as the prize for 32, which was given to Heisenberg. So they were all 3 there on the podium, which was a nice occasion. And there are famous pictures of that if you look at them. So 2013 was the first meeting was September 11, the second was in September 25, and after that it should be total silence. And I would say that it works, people are really keeping silent. And then that year, on October 8, there was this meeting. And then, as some of you have heard, this is a very important telephone call to you from Stockholm. Please do not hang up. I heard a story about chemistry at Caltech, which was awful. They didn't get hold of the laureates, so they called his colleague in the middle of the night to ask his telephone number. We don't do that in physics. Now I have some random pictures. December 10, this is my friend Pierre. And then you might say, why was he there? Well, then you can understand. What year was that? 2008, the prize to Nambu. And of course, he had written a report on Nambu. So he got an invitation. Other people have got invitations too, giving it goodbye. So this is how it looks like. I don't know what year this is. It's a bad picture, but there are the laureates. Here are the physicists. Starts with physics. The royal family. The prize committees. And also behind here. And then someone has to introduce the prize. And this is again from 2008. And there's some text. And then since there were 3 Japanese, I don't know if there are any Japanese here. This is what I said at the end, which I had practiced on 2,000 times. This is the translation. And David and Alan, you know how you are addressed. So this is, and the king, then hands over the prize. I guess it's again the Kobayashi in Moscow in 2008. Those are the random pictures that I have here. And apart from the money and the medal, there's also a diploma, which is usually done by some rather famous artists. So whatever this picture has to do with their prize this time, I'm not sure. I don't think they asked me about it at the time. In the case of Nambu, they was very special. Of course, Nambu had got it rather, how should I say, too late in his career. Fortunately, he was alive, I was nervous the whole year, and I cannot go around and ask you how is Nambu. So every time I met someone from Chicago, I had to go through all the physics department asking how they were. Then I said, and how is Nambu? And also when we called him, I was so moved, so I could hardly speak. But his wife was not well, so he got the prize in Chicago. Unfortunately, Chicago is sort of 7 hours behind Stockholm, so we could send the film from Stockholm to Chicago. They could take part of it, my speech and then my Japanese, and they could even have the translation, so it worked pretty well. He got it from the Swedish ambassador, and he was very happy. Then there's a banquet for 1,300 people, and the food is okay. What you say, David? Yeah, and pretty good wines. And then it ends with, not for the laureates, but for the common people there, with some dancing. Here you might see a picture. This is what we the sort of the pedestrians can see. There's on this table are the laureates and the royal family, and the more common people have to sit, at other tables. This is how it looked from the front. Really, you look a little bit tired. And that is, if that was, that was for good reasons.
There was an election that year, too.
2004, oh, yes. Okay, yeah. This is François Anglaire, and in 2013, he had never had tails before. And there is his diploma, and perhaps this has something to do with spontaneous symmetry breaking. It's beautiful, but then I was somehow involved with the artist. I was explaining it, but she sort of interpreted it freely. Well, this is interesting, because I said that when Nobel died, his wealth was enormous for the time. It was an enormous amount of money, and they had to realize all it and put it into safe bonds. And so this is essentially, the sum of money, price amount, and you see it was more or less stable. And if you take into account inflation, you can see how it dipped, a factor, well, it's hard to say, 20 at least, when it comes. So the idea from Nobel was that someone getting this prize should be independent for the rest of life. At the time of 65, when Feynman, Tomonaga, and Schwinge got it, you can see that was really a low mark. And Feynman used his money in his house in Baja California, I think. Then it started around here, they were allowed to invest, on the financial markets again. And then you can see what happens. They were very successful for quite some time. And then they were not so successful. But it caught up. But even so, those people down here were happy enough, even though the money was not as it used to be. So let me end by going back to Albert Einstein. This is his diploma. And at that time, they didn't have any art. Well, there might be artists doing that, but and you cannot see the text here, but I will translate it and give you what it says. Here it says that it's given blah blah, and then it says, independent of the value which, after possible confirmation, may be attributed to the theory of relativity and gravitation, give the prize which for 1921 blah blah blah, for his contribution to the theoretical physics and especially for his discovery of the law for the photoelectric effect. It's a bit of a disgrace. But he got, of course, Einstein had been waiting for it for quite some time, of course, and he had even promised Mileva, his first wife, that she would get the money. And that was important for her eventually. And she survived. She bought some houses in Zurich and lived on that. And but it's interesting. So I learned the other week when I was talking for the Einstein project in Pasadena that they've gone through all his letters. And in September of 1922, he gets a letter from Arrhenius telling him that Arrhenius knew that Einstein was going to Japan for a long trip and said, please, can you delay your trip to Japan because we want you in Stockholm in December. I didn't know about that until now. So that because at that time it was advertised in November, and of course people were usually living rather close to Sweden at the time, so it was easier to travel. But even so, but he didn't change his plans. Because then there was a discussion, who should receive the prize? Should it be the German ambassador or the Swiss ambassador? And in the end, nobody was there to take it. There was some kind of ceremony in Berlin later. And then in 1923, in the summer, he came to Sweden to give his Nobel lecture. And he was doing that in my hometown of Gothenburg. There was a physics conference. They had a sort of a World's Fair in the town at the time, and they had a physics conference. And he came from Berlin with a train from Berlin. He spent the day in the archipelago and was, going to some dinners. And then he gave this talk at this conference. And you can imagine what he talked about. He talked about general relativity. You can see even the Swedish king is sitting here. So at that time they had changed their mind. Sitting there. You can see some people here who are firmly asleep. So much was it for their interest in the subject. It was probably a very esoteric subject to most of these people there. But anyhow, he came. And he's the only one who is giving his Nobel lecture in Gothenburg. And I think that's we should keep it like that. So, thank you.
Okay, I think Lars didn't talk for 2 hours.
No. So we still have an hour for questions.
No, I know. It says 4 hours.
Yeah, I saw that.
So we have time for questions. I'm sure there are many questions. Yeah.
How is the limitation of number 3 of the recipients instituted? And since it's not in the will, can it be changed?
In principle, it probably can be changed. One can try to make. Of course, if you want to make a change, that has to go through some state organization that can decide, say yes or no. So that was in the beginning, as it was not written. So So it was more formalized to be 3 rather early on. And but in principle, one can, foundation can change the rules, but it's very difficult.
Back there.
Do you have an understanding why people, theoretical physicists that get the Nobel Prize and the later stage of their careers start kind of believing that quantum mechanics is not in and they want to again get classical?
Not universal.
Sorry, I didn't get last.
No, so people like Radhoft and Lambert, they really want to, Einstein actually, they all have an aversion for quantum mechanics and they want to kind of come back to a theory, classical theory for quantum mechanics.
Well, if they make a discovery, they can get the prize, But
I think you're asking why?
Yes.
Well, first of all, it's clearly not universal. And second, that's a disease that afflicts many people, not just Nobel laureates.
Jim.
In the citation for the 21 prize, gravitation is mentioned. Was it thought that prize was already, so to speak, enough recognition for general relativity? Was it enough for a recognition of general relativity, or did that subject come up again? And if so, what happened?
No, but here it said irrespective of the value of it. So they clearly didn't take any. It sounds as if they were not really believing in it the way, or they were doubting, which is surprising after Eddington's experiment. The solar eclipse. Well, then you have I don't know. I haven't really checked that, But my
stories about certain members who were very influential who didn't even believe in special relativity.
Yeah.
And it looks that I never saw that preface before, but it clearly says we, by giving this prize, are not affirming, even if it's later affirmed.
No, so in that sense, one could have come back, but because it's difficult to get the second prize, and at that time, they didn't even think about it. So there's not been a prize for it, yes. I was sort of soliciting a question, but nobody about the prize in 57. Do you have a good question about that? Lee and Yang.
Oh yes. Well, so you sort of gave an answer, it seemed to me. So the question is obviously why didn't Madame Wu share the prize? After all, she made the experimental discovery that confirmed predictions. Actually, they didn't even predict that parity would be violated. They simply said that's totally possible, and it would be perhaps useful for
check.
What?
To check.
Yeah. To check, and she actually did the experiment. But you said, I didn't ask the question because you sort of gave the answer. You said that there were other Letterman
and Telegdi and Friedman,
which was almost
the same. But Madame Wu somehow has priority, and that's why she was first.
So explain.
It's a good question. And really, if you read their paper from 56, they in the acknowledgement they thank her, and it's clear that she was the one to propose even that they should check this cobalt 60. So evidently she was heavily involved in the work. They wrote the theory somehow, and she said, well, this can be tested, and she tested it and found it. And
But she could be nominated for a different prize, right? Madame Wu.
Well, she could have been, David. But you remember when we were in Singapore, Frank Yang was sort of asking me. He said, "Why didn't Madame Wu get the prize?" I said, "I don't know." I asked him, "Should she have been given?" "Yes," he said, like that, very, very determined. And in fact, both Lee and Young, so much I can say, they tried hard, after, but somehow the committee at the time was not interested. And I think that it was too quick. The committee worked. They were so happy to have these two young. They looked, like kids, and to give them prize for such a fantastic discovery that they immediately took it. Had they waited a year, they probably had realized that she should have been on it, which I think would have been better.
Was she nominated?
Oh yeah, I'm pretty sure you can. Yeah, you.
It differently. So this is not open yet. Right?
No, not 57 is, but you can see.
Because there's
No,
still
57.
Right?
So actually, you can see in 57. You can check 57, but if you look at 57, you will not see any nominations of Lee or Young. They have been taken away.
Okay, so you can't tell who's nominated, but you can.
But in 58, you can check.
No, but 57 nominations from Nambu.
There were probably none.
There were none.
No, I mean this is open. In principle, you can check it. I don't remember, but I'm pretty sure.
There is this rule, right, that unless
you have to. That's why I also said if they had waited another year, there would have been nominations for her too, I think.
But actually, I had a more subtle question. If 57 might be partially closed, but is it actually the case that when you open these files, you can figure out what the deliberations were and the reasons of the committee, or does that actually appear in these records?
Oh,
Are there minutes?
No, but one can read this report that the committee wrote at the time, and then it's clear, and so the scholars can eventually look at that and see how they thought.
Well, the reports aren't the same as the deliberation.
No, it's true, but...
Is there any record of second place? The committee must come down to a short list, right?
Yeah.
This person.
Yeah.
Is there any record of a short list, or is it just the final?
You can see a short list, but it's not written as a short list. But you can see there would be people. There would be in the report statements that this has been worked through and that this is okay for a prize. But then how it's weighed with the others is not there, because in the end it says, and this year's prize should be given to them.
This is the Institute of Theoretical Physics. Can you say more about the prohibition on theoretical discoveries being recognized unless they're confirmed, and whether that's ever possible to change?
Not unless they are, experimentally verified. But then, in the 50s, actually, the Nobel Committee was strongly influenced, and they had strong people in theoretical physics at the time. That Oskar Klein, Ivar Waller, and they were rather dominating figures in Swedish physics at the time. So that's why there are some theory prizes at the time. On the other hand, you might say that if you look at Feynman compared to the experimental discoveries, what's his name? Lamia Redford, which was more than 10 years before, so it took quite some time to get to the theories. Even though, you would say that it would have been experimentally verified by the Lamb shift, their work. So it's...
I was actually this one, I was collecting about Lisa Meitner, right? Which
Yeah.
was another story about
Yes.
woman who kind of clearly deserved your prize, right? But
Well, yeah, this Meitner is a bit of a sad story. She came to Sweden in 1938 and, as a refugee. She was working in Sigvan's laboratory. She had her own laboratory there. Of course, not as well equipped as the one she had in the Kaiser Wilhelm Institute in Berlin. But of course, Siegmann, who was a Nobel laureate from 1924, was not very happy with having her there. She had been brought there by Oskar Klein. Oskar Klein was, helping Jewish people from Germany, and Oskar Klein had more or less they used to call it a hotel for people, coming and eventually going, so Siegmann was not so happy, and I think he was destructive here. Of course, it would have been a very nice prize to give it to Han in chemistry and to her in physics, which would have been natural. And they missed that, which I think is very sad. So it's, well, it's a pity.
They can make mistakes.
Yes, no, there are mistakes, yes.
I have a question about dark matter. I don't believe there's been a prize.
No.
Yet there's overwhelming evidence for dark matter at different scales in the cosmos, but yet the Academy did give it for the accelerating cosmic expansion, which would seem to be jumping over a step, if you ask me. But is there anything you can say about?
No, but I mean, No, but I can. If you read the history books, you can go back to 1938 or something to Zwicky, so you can start there. Yeah. And he didn't get it, no.
Well, but that was.
So it still could be.
What?
Yeah, there could still be a prize then. Yes. Yeah.
Dark matter is still out there. Okay, well, let's thank Lars again for a very...
Good.